Okay, we're going to be looking at some special limits for trigonometric functions in the next couple of videos. So here's the first theorem, really. And I'm going to rewrite it because I don't like the use of x all the time. So what I'm going to do is I'm going to rewrite the theorem and replace x with u. So let's say u approaches 0 for some function. Sine of u over u. Well, it equals 1. Now, there is a way to prove this, but we're not going to get into detail about that. We're just going to learn how to apply it. Now, u can be anything so long as whatever u is matches whatever the u is in the denominator. So, for example, if I see on my problem number 4, I have the limit as x approaches 0 of the sine of 5x over x, the limit theorem doesn't apply right away because 5x in the numerator also must have a 5x in the denominator. So what I tell my students, and I learned this from another mathematician, James Tanton, who just does some awesome videos about really lower levels of math, but I mean his ideas are amazing. But anyway, he says this. He says, if you want something in life, make it happen, and then deal with the consequences. So if you want something, in this case, a 5 in the denominator, then make it happen, but deal with the consequences. The consequence of writing a 5 in the denominator is that I must also write a 5 in the numerator, because the only thing that I can do is multiply this by 1. Okay? So I'm going to then see that it now follows my limit theorem. I'm going to put a ring around it. So there, right there, it says sine of 5x over 5x. So this follows this theorem over here. This follows this theorem over here, that the sine of 5x over 5x for the limit as x approaches 0 is just 1. So now what we have is the limit as x approaches 0 of 5 times 1, which is the limit as x approaches 0 of 5, and the limit of any constant is the constant itself. So the answer is 5. All right, now let me write that down. This is important. The limit of any constant is the constant itself. All right, so keep that in mind. The limit of a constant number is the constant itself. All right, let's take a look at one more example here. I have x over the sine of 3x. Now you may be thinking, well, that doesn't look at all like the theorem. But let me add that this theorem can also be written as such. Let's say u approaches 0 of u over the sine of u. All right, it still equals 1 because the ratio gives you 1 in terms of the theorem above. So it doesn't matter. All right, but the same rules apply. If you want something in life, you make it happen. We notice that we have x over the sine of 3x, and that's great, but we need a 3 in the numerator, so I'm going to make that happen. I'm going to write that in, but the consequence of that is that I must write a 3 in the denominator. Okay, so now that it's all set, I can put a ring around it like this. This right here is going to go to 1, and I am left with the limit as x approaches 0 of 1 over 3, which we said earlier that the limit of any constant is the constant itself. So right here is my answer, 1/3. Okay, so just a little application of these theorems for trig functions. There's another one for cosine, but we'll get to that in the next video. But it's relatively easy. It's a really nice application. I hope this was helpful. If it was, always remember, like and subscribe.